Welcome to our latest explainer. Have you ever stopped and literally just thought about how you actually know your way around? And I don't just mean checking your phone. I mean the deep, fundamental mental wiring that tells you up from down, left from right, and north from south. Well, today, we're diving into an absolutely fascinating piece of text, Chapter 14, that builds out this entire concept of spatial awareness, step by step. We are going on a journey from using the actual sun as a compass all the way down to understanding pure mathematical coordinate grids. It's a genuinely incredible look at how we learn to navigate our world.
Here's the game plan for today. We're going to build our navigation knowledge block by block, looking at directions in nature, mapping immediate spaces, navigating streets, and finally, plotting grids and coordinates. Let's get right into it.
Starting off with Section 1, Directions in Nature, basically our natural compass.
What's so brilliant here is how the text places you directly into the environment. Imagine you're standing outside right now, in the shoes of a boy named Manu. If you're standing there facing that bright rising sun, you are looking east. But here's where the act of learning kicks in. If you are facing east, which way is directly behind you? Which way is west? It instantly forces your brain to orient itself in physical space.
The really cool thing here is that by simply using your own body and the sun as your primary anchors, you can map the entire rest of the world. If you're facing east towards that sunrise, your left hand naturally points north and your right hand points south. In just a few seconds of observation, boom, we've established our fundamental cardinal directions. It's an incredibly empowering realization, you know? Your body itself is literally a compass.
And we aren't the only ones doing this. This perfectly illustrates how our human observations parallel nature. Take the magnificent Siberian crane. The text drops this amazing fact: these birds migrate thousands of miles from the freezing cold of Siberia all the way to a sanctuary in India. Now, how do they find their path without a map? While they might use magnetic fields or stars, we humans use the rising sun. It just goes to show that navigating our world is this massive shared survival skill across species.
Moving right along to Section 2, Mapping Your Immediate Space, where we shift to local geographies.
Okay, check out this wonderfully illustrated birdwatching camp. Notice how we're no longer just relying on the sun, we're leveling up to a top-down map. The chapter cleverly asks children to use relative directions to color in specific tents, like it asks you to find the tent to the west of the road and make it blue, or the tent closest to the lake and make it green. We're learning to describe where something is by referencing the stuff around it. That's a completely different mental muscle than just pointing north. Then, the chapter zooms in even closer to a super familiar setting, the single bedroom. Notice how the girl is placed exactly in the center of the room. That is highly intentional. It establishes a personal human point of reference. We're moving from, hey, where is the tent relative to the lake, to where are the objects in this room relative to me?
So let's actually try this for a second. Imagine you're standing exactly where that girl is standing, facing forward. In which direction do you have to move to reach the bed? Or what about the cupboard behind you? By answering this, you're transforming yourself into the absolute center of a customized compass rose.
All right, Section 3, Streets and Routes. Time for the macroscopic journey.
Picture this. It's 8 a.m. We've got these excited kids waiting at stop 1. The scenario tells us they're waiting for the school bus to take them on a thrilling field trip in Delhi. But to pick them up, the bus driver has to know exactly how to navigate the neighborhood.
And think about what the driver has to deal with. To get to those kids, the bus has to navigate this increasingly complex street layout. It's no longer just a room with 4 walls. We're juggling varied landmarks now. A hospital, a basketball court, different houses. This is a massive test of spatial memory and route planning. Let's trace the exact route the chapter lays out. The bus starts way down at the parking area. First, it heads straight north. Then, it has to take a right turn onto Hospital Road. Finally, it drives east to successfully pick up the waiting students at stop 1. We are actively combining cardinal directions, north and east, with relative directions, taking a right turn, to successfully navigate an urban grid. It's all coming together.
And then, the chapter throws a real-world curveball, scaling this up to a public transit metro map. It's literally teaching kids how adults actually navigate subways. It challenges you to identify colored lines, figure out where to switch lines at transfer stations, and critically, how to calculate routes with the absolute least number of stops. This is high-level problem-solving wrapped right into a daily commute.
Finally, we hit Section 4, Grids and Coordinates. We're crossing over into pure mathematical abstraction.
Take a look at this comparison right here, because this represents a massive cognitive leap.
We are moving from describing where something is based on what it's next to, like, oh, it's just left of the hospital, to using absolute, exact, unchangeable numerical coordinates, like 0.4, 1. A coordinate doesn't care which way you are facing. It is absolute truth on a grid.
And the textbook drops this beautifully elegant instruction. First move horizontally from 0 and then vertically. That simple sentence is the foundational rule for reading an X and Y coordinate graph. You run along the hallway before you climb the stairs, right? It's a rule that applies from a third-grade math book all the way up to advanced calculus.
Let's see this in action. By cleaning up the visual grid data into a neat little table, we can easily locate exactly where any animal is in the zoo. For the tortoise, we move horizontally to 4 and vertically to 1. By plotting their intersection, boom, we find the animal. The textbook asks you to reverse engineer this too, like what animal is sitting at 11, 11? It totally gamifies the whole Cartesian coordinate system.
So let's wrap up this explainer with a pretty wild thought. How does plotting a cartoon tortoise on a simple paper grid map directly to the GPS satellites orbiting the Earth right now? Well, it's the exact same logic. These childhood exercises, facing the sun, navigating a map to the zoo, plotting coordinates on an XY axis, are the foundational building blocks that allow modern GPS systems to guide us around the globe today. The screen in your car is just a highly advanced version of this exact chapter. So next time you're blindly following your Maps app, just remember, you're really just finding the tortoise on the grid. Thanks for learning with us today, and keep exploring.